So this is the way how we draw this ring chain isomers. Hello everyone, welcome back to Plutus STEM. Today we are going to discuss regarding ring chain isomers. As you are aware that we are discussing the isomerism from quite few videos. In that we have discussed regarding the structural isomers, and in that structural isomer we have been discussing regarding the position isomers, chain isomers, and in the previous video we were discussing regarding the functional group isomerism. So before moving further, I want to tell you RTF MCP. This is the thing. I have already told you while I was telling you regarding the isomerism. RTF MCP. Yeah. So what is this? This is a ring chain. This is a ring chain isomers. This is tautomers. This is functional group isomer, metamers, chain isomers, and position isomers. So these are the different structural isomers, and this is their priority. This is their priority level. So this position chain and functional group, and this ring chain, we call it as a subpart sometime of this functional group isomers only. But if it is being asked separately, then it is having a higher priority than functional group isomerism. So what is this ring chain isomerism? So before going to that, I would like to tell you a thing, that is DBE, double bond equivalent. So before moving to this ring chain isomers, we need to be clear about this thing, double bond equivalent. There is a formula, carbon plus 1 minus H upon 2 minus X upon 2 plus N upon 2, like this. There is a formula like this. So with the help of this formula, what we can do, we can find out the double bond equivalent. So if we now we will be going to this like say if we are having this thing, how many carbon are there? Molecular formula of this compound, CH2 CH CH3. Carbon is 3, hydrogen is 3 3 to 5 or 1 6, C3H6. So just I have drawn this structure. If we are not knowing the structure of this compound, and we know that the C3H6, okay, we have made some mistake or not? Yeah. No. So this, if you see the, find out the dB of this value, how many carbon are there? 3 plus 1 minus how many hydrogen are there? 3 to 5 or 1 6. So like 6 upon 2 and no halogen and etc. thing. So 4 minus 3. So dB will be 1. dB of the C3H6 is 1, which means there need to be a either one double bond or one cyclic chain. Either a double bond or a cyclic chain. The possibility is that either one double bond or one cyclic chain. So this can be made like this or not. So these two are ring chain isomers. These two are ring chain isomers. Clear or not? The name of this compound, if we want to draw, we can tell this acyclic compound is methane 1 2 3 eth, 3 carbon prop 1 ene, and this is 1 2 3. A cyclo group is there, cyclopropane. So we can have some more example of this ring chain isomers. 1, 2, 3, 4, 5. If you want to calculate the dB of this compound will also be equal to 1. dB of this will be 1. So 5 carbon are there and 1 double bond is there. So this can be drawn like this. These two are functional group isomers. These two are functional group isomers. Sorry, ring chain isomers. CH2, CH, CH2, CH2, CH3. 3 or 1, 4. 2 to 4 and 5 or 5 or 6, 11. C5H11. Yes, and regarding this, okay. Sorry. It is CH2, C5H10. C5H10. Or for this also C5H10. Regarding this molecule, two, 4, 6 or 4, 10. C5H10. So this is also a ring chain isomers. And one more example if you want to see, this is also a ring chain isomers. All are having dB value is equal to 1. 336 hydrogen like this. Clear or not? Yeah. So this is the way how we draw this ring chain isomers. And if we are having a group like this, the confusion starts at this point. This one and this one. So if you see over here, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, C5, 2, 4, 6, 8, H8O. Over here, 2, 4, 6, 2, 4, 6, 7, 8. Clear or not? So C5, H8 again. So these two are, these two are ring chain isomers, or you will call them as functional group isomers. The problem arises over here. So I have told you the priority level. Ring chain is having a higher priority compared to this functional group isomers. Clear? So they will be termed as ring chain isomer, not functional group isomers. If you are not given with the option of this functional group isomers, ring chain, then you can just name them as a functional group isomer also. But on the basis of priority, they are ring chain isomers. One more, if you see, CS3, 2, 4, 6 or 4, 10. They are ring chain isomers. This one is ether. This is a ether substituent. This is a alcohol. This is a ketone. But all of them are ring chain isomer. Sorry. No, I'm really sorry for this. These all not ring chain isomer of each other. They are ring chain isomer of this compound. This one. One, two, three, 4, 5. This one. Yes. How many carbon are there? 5. C5. How many hydrogen? 1, 2, 3, 4, 5, 6. 1 2 3 4 5 carbon. 1 2 3 4 5 carbon are there. 3 or 1 4 or 1 5 to 6 to 7 or 1 9. Yes or no? So these all, this is, let's say this is 1 2 3 4. This one is a ring chain isomer with all these 4, with this also and with this also. These are like functional group isomers only. These are functional group isomers of each other. Clear? And if you see over here the dB value, if you want to calculate the dB value, it is going to be coming to be 1. How? Carbon 5, 5 plus 1 minus 8 by 2, 6 minus 4, that is going to be 2. 2 means 1 dB for this double bond and 1 dB for this double bond. In this 1 dB for cycle, another for this. 1 for cycle, 1 for this. 1 for cycle. I think we have made some mistake over here, yes? This is not a 3, 1 4, 3 to 2 to 4 to 6, 1 7, 8 9 10. How is it possible? Two to 4 to 6 and 3 9, 2 4 6 or 1 7, 4 carbon and 1 5 carbon over here. 2 4 6 8. In this C4H8 and here 2 4 6 7 8 9 10. So this is not these are not same, because so this is a very good thing that we are being confused over here. So it helps us a bit more that this one. These are not functional group isomers and these are not functional group isomers. So over here one more thing we have got by this confusion, that this thing, this is having a different molecular formula, C5H10O. So they are different molecules. These are different molecules. Clear? This one and this one, they can't be isomers. These are different molecules. This is having a dB value is 1. And all those isomers, they are having same dB value. It is a very good thing that we are being confused over here. So one more concept is being cleared with the help of this, that this, sometimes we don't see the thing and just we go through this, like I have done in this example. So this is like, they must have, the first condition is same molecular formula, and this compound doesn't have the same molecular formula as all these 3. So this 1 2 3, this 4 will be not a isomer only. This is a different molecule. These are like same functional group isomers of each other. They are functional group isomer, they are chain isomers, ring chain isomer. This one is ring chain isomer, and this is a different molecule we have seen over here. If we are having this type of molecule, how many carbons? 1 2 3 4 5. 1 2 3 4 5 carbon, like this OH. This thing or not? Same. Can we draw it like this or not? The same thing. This thing also and like this also. So this is also a ring chain isomer of this. And these two acyclic compound, they are combinedly, they are as a functional group isomers. So these two are ring chain isomers. So while solving these type of question, the first thing you need to keep in your mind is their molecular formula need to be same. Their molecular formula need to be same. Clear or not? So this is the thing. This is for your ring chain isomers. Just a quick review we will take of this. We have already discussed all these isomers. So in ring chain, the first thing I have told you regarding the dB value, I have shown you different ring chain isomers. This is another example of ring chain isomers, and many more examples are there, but it is not that much quite important. In the next lecture, we are going to discuss about a very important topic, that is metamers. We are going to discuss about the metamerism or metamers. That's all for today. Thank you.